We're searching for meanings to keywords, and we're investigating and completing calculations for Ohm's law. This is the basics of how electricity works. If you actually think about an atom is made up of neutrons and protons, which make up the nucleus, and electrons in shells around the outside. Your neutrons are neutral, they have no positive or negative charge, but your proton is positively charged and your electron is negatively charged. And if you've got a balanced atom, you'll have the same number of electrons in the shell as you have protons in the nucleus, so that there is neither a positive or negative charge, it's neutral. Now, some materials, these electrons are solidly bound to the atoms and they're going nowhere. But in other materials, they're more loosely bound, so particularly in metals. And sometimes the electrons from the outside shell can move from one atom to another. If they do, they become a free electron and they can move on to a different atom. The nucleus, the protons and neutrons stay exactly where they are, so that the material is still exactly the same material as it was, because it's the protons that define the material within the periodic table. And where that free electron leaves, that leaves a hole in the outer shell, which makes the entire atom positively charged. So it's actually a positive ion rather than an atom now. And your free electrons wandering around looking for a new home. Now, if your material is a conductor, it's going to have lots of free electrons that are going to move easily from one atom to another. If it's an insulator, there'll be no free electrons. There's no movement, so no electricity no electric current will be generated. If you were looking at a standard piece of material, your free electrons are going to be moving around randomly inside of it. So if you're thinking of this as a battery that wasn't connected to anything, then you're just going to have free electrons moving from one atom to another with no particular direction. However, if you have got a potential difference, in other words, a voltage, power supply, possibly from a battery, then that is going to give you a positive and a negative, and your electrons are going to be attracted towards the positive side of the battery, and the holes that have been vacated by the electrons are going to move towards the negative side of the battery. And that's what gives us our flow of electric current, those electrons moving along a wire from one atom to another, but in a specific direction caused by the potential difference. So you needed a definition for a proton, and it's part of an atom which is positively charged. It's in the nucleus of the atom. The electron is one of the subatomic particles that are orbiting around the nucleus, and they are negatively charged. The current is the flow of electrons from one atom to another. The potential difference is the pushing force, or the voltage, which is pushing the electrons around the circuit. Your resistance is if there's anything there that is going to slow or inhibit the movement of the electrons. So it could be impurities in the material, it could just be that it's harder for the electrons to move because they are more tightly bound to their atoms. Ohm's law we're going to be discussing in a minute, and it is basically the principle that your voltage, your current and your resistance are all linked mathematically. Voltage, potential difference, is measured in volts. Current is measured in amps or amperes, and resistance is measured in ohms. So, looking at Ohm's law, if we just start thinking about resistance in the first place, if we compare electricity to water, and we think of the flow of water as being the same as the flow of electrons, we can reduce the flow of water by restricting the pipe the water is going through, and that restriction is the same as a resistor in electricity. Because we've reduced the flow, we've increased the resistance, we've reduced the flow of water. So the bigger the resistance, the smaller the current. I love these little guys here. And that's what this formula is. Voltage, which is your pushing force, is equal to the current, I, this little green guy here, times the resistance, R, which is the little red guy. So voltage is equal to the current times the resistance. Now you should have seen these triangles before in science. If you want to calculate the voltage, you put your thumb over the V and that gives you the formula you need, which is I times R. If you want to calculate the current, you put your thumb over the I, so it covers it up, and that gives you the formula V over R. If you want to calculate the resistance, then you put your thumb over the R and you get the formula V over I. So one more thing you need to think about before you start doing the calculations, which I'll talk about in a minute, and that's what's called SI prefixes. Now you've come across these before. If we talk about things being measured in meters, you will know that there are 1,000 millimeters. So if we look at this one, 1,000 millimeters in a meter. Equally, there are 1,000 meters in a kilometer. So these you are used to seeing, but you need to remember to use them within electronics because often you are working with millivolts or milliamps, or you're working with kiloohms. If you forget to include this information in your calculations, you might get the right significant numbers but the wrong multiples. Okay, so we're going to look at how to use Ohm's law. We've got the formula triangle in the corner here. Here's my question. If I, which is the current, equals 0.5 amps, or half an amp, and R equals 200 ohms, what is the voltage? So if we want to calculate the voltage, we say cover up the V. So that makes our formula I times R. So that is 0.5 times 200. And that is going to give us 100 volts. So looking at Ohm's law again, my formula, VIR, if V, we've got voltage, we've got resistance, we need current, so we cover up the I. So that gives me a formula of V over R. Voltage is 9 volts, so that's 9, and resistance is 1K. Now we must remember that is 1,000 ohms. Remember the SI prefixes. So that gives us an answer of 0.009 volts, or if we want to convert it into a simpler number to read, we could write it in millivolts, in which case it's 9 millivolts. And the final one, this time we're calculating the resistance. So if we put R equals and cover up the R, we've got the formula V over I. V is 6 volts and I is 0.05 amps, which gives us an answer of 120 ohms.